Hello, everybody. Activist Victor here, and well, this is one of my first alert networks I've done in a long time because, as it turns out, there is an enhanced risk of severe thunderstorms as predicted by the SPC on day 3, which now that it's Wednesday today, would be Friday. Probabilistic, this is the percent chance that one of these will occur, that some severe event will occur within 5 miles of a point. So, no, 25 miles of a point. 5 miles of a point. Yeah, if it was 5 miles, that would be a little bit more insane. That'd be like a high risk, exceptionally high risk. So anyways, like that means that in a given scenario, I think 30% of the time you get severe storms within 25 mile of a point within this region. And hatched area, which there is none, is significant. So yeah, I'm going to look at the... So yeah, I'm on the College of DuPage Meteorology tab right now, and I'm looking at the NAM model to try and see exactly why this severe event's probably going to occur. So we're going to look at moisture, instability, and frontal forcings. We'll look at the surface products, the temperature, and I believe is this the temperature. So let's see the front that's supposed to come through. There's your low pressure system at the surface. Wow, look at that. Look at that bugger. Now you can see the front right there. So it looks like there's going to be a warm front that comes through. I mean, it looks like the cold air is going to sag south a little bit, and then it's going to go back north under the influence of this low. And there's your front that's probably going to kickstart all of this. And there's some pretty nice moisture. For February, I mean, look at that. That basically indicates what temperature you'd have to cool the air to in the air outside in order for it to form into clouds or condense into liquid as opposed to staying gaseous water vapor. And the 56, 57 values, that's higher than the average temperature in February, so that's pretty dang moist for this time of year. Yeah, there's the 45 going south a little bit, but then it's going way back up underneath the influence of this low pressure system. And then it'll get way less. So there's definitely moisture present here. Instability and shear, what we want to look at next. So surface-based CAPE. Basically, this is a measure of how much energy the severe storms would have to tap if they were to form. And the hatched area is the amount preventing them from forming. So that basically means that there's some sort of unfavorable area in the atmosphere the atmosphere is going to have to warm up to overcome before it can use that CAPE. But that's not necessarily a good thing because you can sometimes get exposed to development. Like it's like putting a pot lid on a pot. You know, you heat the water up more before it boils since the water can't actually go out of that area in the pot so that when it does boil, boom. So there's no inhibition on this day, it looks like. Oh, there's some inhibition. Oh, look at that. There's none. So we're getting about 1,500 CAPE. That's not, like, huge, but it is pretty significant for this time of year, I will say. So, yeah. Valid 21Z. That's like 6 o'clock. 3 to 6 looks like when this is saying it's going to happen. And... shear. So that's basically a measure of how much the wind direction changes from the surface to the upper levels and how much the speed changes. So this looks pretty strong. Wow, that's actually not that bad. So I can see where they're saying that something could definitely happen in Indiana. Now, we're going to look at the GFS or another model just to see how it compares. Because obviously one model saying something, if another model says something completely different, one of them's got to be somewhat wrong. So now we're going to look at moisture and source of lift. Well, first we're going to look at source of lift. Could something start that parcel up over that initial resistance that the air above the ground typically has to stuff so it can tap that potential in the higher atmosphere? And yeah, I'd say frontal forcing's definitely present around here. To the north of the warm front, and obviously over here as well, it has the low going pretty much the same area. Then we'll have moisture, precipitation. No, surface products. Dew point. Yeah, anything green is abnormally high for February. It's about the same, to be honest. So yeah, it's going in this same area right here. Either way, that's more than enough moisture to sustain severe weather. And you can see that dew point boundary just go through. Look at the dew points plummet. And again, this indicates how cool the air would have to cool to in order for like the surface air to become like foggy. And I'm not saying that's going to happen, but obviously the higher the number and the less it has to cool, the more moist the air is. Because warmer air can hold more water vapor. And if you have air that only has to be cooled to 50 degrees in order for it to condense, it has more water vapor than air that has to be cooled to 40 degrees in order for it to condense. Source of lift and moisture. So now we're going to look at instability and shear. So we're going to look at CAPE, which stands for convectively available potential energy, in case I didn't mention that. Kind of tells you exactly what it's referring to. How much energy does a potential convective system that forms have to tap into? This doesn't have nearly as much as the NAM does it? Yeah, so this is looking like the CAPE situation's not nearly as good for this model as the other one is. So obviously, yeah, there's some discrepancy between the models, as you can see. And this also has some inhibition throughout the period. So I think the front will still be able to overcome it, but you never know. It seems like it will probably be more front hugging in this situation than potentially forming cells ahead of the line that could maybe spin up into tornadic systems easier. And bulk shear. It's today, and then we're going to go through this. So this does pretty nice shear. In terms of, yeah, this looks like pretty strong shear. So, yeah. And I probably should have looked at helicity, which indicates it's like a lower level rotation aspect. Wow, look at that. That's obscene. But when it comes through us, wow, that's actually not that bad. That's actually not that bad at all. So there could be a tornado threat, maybe. But obviously it's too soon to tell for sure. And let's look at the NAM helicity just to compare it. I should have done that earlier. And I mean, again, it doesn't mean there will be tornadic activity. Oh my goodness. Oh my goodness. It's about the same. Oh yeah, that's actually more. So the NAM definitely looks like it's saying this is going to be more robust, while the GFS is a bit more conservative, although it still agrees that something's probably going to happen. So based on these models, I would definitely agree with where they're putting this severe storm risk. The greatest risk is clearly in this area, but obviously, as we can see, it doesn't mean it's only going to occur in this area. There's like a curtain around it here where there's a decent chance, and there's like a somewhat chance here, and then this is probably just going to be generic thunderstorm. So that's the alert network for you. Hopefully I didn't say things that went over your head. I feel like I explained it pretty well, but if you have any questions, feel free to ask me in the comments. And I'll try to keep an eye on this situation to keep you informed, and I'll post some links in the description so that you can look at the information and be informed as well. So remember, stay safe and keep on top of the situation. You should be just fine. So this is me signing off.